So in this video, we're going to talk about Module 1, Topic 2, Lesson 6. This is Part 1. So in this first part, it says, consider the function p of x equal to x squared plus 1 in its graph below. Find the zeros of the function. So when it tells us to find the zeros, when it tells us to find the zeros, what we are looking for is where the graph crosses the x-axis. So if we look at this graph right here, notice that it's crossing the x-axis, or that's where the x-axis is, okay? And notice that our function is not crossing the x-axis at all. The lowest it goes is at +1. So what this means is that this has no real zeros, okay? And so sometimes the graph doesn't actually show us the zeros that we need to see. And this leads us into that imaginary number I. Okay? So if I squared is equal to -1, then what is the value of I? What that is if we have I squared equals -1 and I wanted to solve for I, we would take the square root of both sides. When you take the square root of both sides, that gets you I is equal to the square root of -1. So therefore, we know that I is equal to the square root of -1. So anytime we see the square root of -1, that is equal to I. Now, some extra information. We have I is equal to the square root of -1. We have I squared is equal to -1. Okay? What would I to the third be, or I to the fourth? Well, I to the third would be equivalent to I squared times I, because when you multiply things of the same base, you add their exponents. So I squared times I is I to the third. Well, we know that I squared is -1, and we can just leave I as I. So what that tells us is that I to the third is equal to a negative I. Okay, what about I to the fourth? I to the fourth is equivalent to I squared times I squared. Well, I squared is -1 times -1, which is equal to 1. So we know that I is equal to the square root of -1. I squared is equal to -1. I to the third power is equal to -I, and I to the fourth is equal to 1. So with this information, now we can find the zeros of our quadratic function p of x. So what we do is we set p of x equal to 0. And to solve, we would start by subtracting 1 from both sides. When we subtract 1 from both sides, we get x squared equals a -1. So then I can take the square root of both sides and I get x equals, remember when we take the square root, we take plus or minus, and the square root of -1 we just learned is I. So the zeros of this polynomial are represented by plus or minus I. Graphically, it looks like this, where it's not crossing the x-axis. So even though this graph did not have any real zeros, it had two non-real or imaginary zeros, I and -I. Okay, so now, functions and equations have solutions requiring I have imaginary zeros or imaginary roots. So how can you tell from a graph of a quadratic function whether it has real solutions or imaginary solutions? So what we know is that real solutions are going to cross the x-axis. So this is our x-axis. So if I have a quadratic function that looks like this, then my quadratic function has two real zeros because it's crossing the x-axis twice, or two real solutions. We can also have real solutions that look like this, where it just touches the graph one time and it turns around, And so that would represent one real solution or one real zero. Okay, now what would it look like if it didn't have any real zeros? Well, if it didn't have any real zeros, it could look something like this. And what that means, and what we have to understand, is that means that there are two imaginary zeros. Okay, so those are your three options for a quadratic function. You can have two real zeros where it's crossing twice. You could have one real zero where it only crosses once, or you can have two imaginary zeros where it doesn't cross the x-axis at all. So now we're going to practice rewriting expressions involving negative roots. So we do have a worked example. So if we want to rewrite the square root of negative 25, what we would do is we would break it up into the square root of negative 1 times the square root of 25. Well, we know the square root of 25 is 5, and we know that the square root of negative 1 is I. So therefore, the square root of negative 25 is just 5i. So we're going to practice that here. So rewrite each expression using I. So we have the square root of negative 4. So what we would do is we would break this up into the square root of negative 1 times the square root of 4. Square root of negative 1 is I. Square root of 4 is 2. So this is equal to just a 2i. Okay, looking over here, we have the square root of negative 12. That would be the square root of negative 1 times the square root of 12. Now, yesterday we did learn, or in the previous lesson, we learned how to simplify radicals that are not perfect squares. So remember, this right here can be split into the square root of 4 times the square root of 3. And so I'm going to go ahead and drop down the square root of negative 1, and then we simplify. We know the square root of negative 1 is I, the square root of 4 is 2, and then the square root of 3 doesn't simplify. So therefore, the square root of negative 12 turns into a 2i square root of 3. Okay, looking at the next one. We have 5 plus the square root of a negative 50. So what we're going to do off to the side is we're going to focus on simplifying this, and then we'll come back and put it in the equation. So we know the square root of a negative 50 breaks down to the square root of a negative 1 times the square root of a negative 50. Then we need to know what perfect square goes into 50 evenly, and that would be 25. So we have the square root of 25 times the square root of 2, because 2 times 25 is 50. So then we have I, square root of 25 is 5, square root of 2 stays the square root of 2. So then we can come back in this expression here and plug that in. So we know we have 5 plus, 5i square root of 2. And that would be the simplified form of that. Okay, looking at the next one, I see that we have another radical that we need to simplify, so let's do that off to the side. The square root of negative 8. So that would break down into the square root of negative 1 times the square root of 8. The square root of 8 breaks into the square root of 4 times the square root of 2. I'm going to drop down the square root of negative 1. Square root of negative 1 is I. Square root of 4 is 2. Square root of 2. So what we know is we have 6 minus, I'm going to plug in 2i square root of 2, all divided by 2. Okay, so from here we need to simplify. When we simplify, you can only simplify the 6 and the 2 on top with the 2 on bottom. The 2 inside the radical is protected by the radical, so therefore it cannot be simplified. So what we know is 6 divided by 2 is 3. 2i divided by 2 is a negative 2i. and then this rad 2 stays the same. It is not affected, and this would be completely simplified. Okay? Now, operating with complex numbers involving I, we combine like terms by treating I as a variable, even though it's a constant. So we want to perform each operation, and we want to show our work. So here, we want to perform the operation 3 plus 2i minus 1 minus 6i. So we're going to drop the parentheses on the first set of numbers. On the second set, when we drop them, we're going to drop them after we distribute the negative. So a negative times 1 is a negative 1, and a negative times a negative 6i is a positive 6i. From here, we combine our like terms. 3 minus 1 is 2. 2i plus 6i is 8i. So that would be our simplified answer. Okay, looking at the next one. Again, we're combining our like terms. I'm going to start with our numbers first, our real numbers, not the imaginary parts. We have 3 minus 6i. That turns into a negative 3. 3 minus 6. Okay, then I have a minus 1. So negative 3 minus 1 is equal to a negative 4. Then I'm going to do my imaginary part. So 4i plus 1i, that gives us a 5i. And that would be simplified. You cannot combine the real part with the imaginary part. Okay, next we're going to multiply. So when we multiply, we do 5i times 3i. 5 times 3 is 15. The I tags along. Then we do 5i times a negative 2i. So 5 times negative 2 is a negative 10. I times I is I squared. So what we need to remember from the beginning is that I squared is equal to a negative 1. So what we have is 15i minus 10 times a negative 1. So this ends up simplifying to a positive 10, and that would be the answer to 5i times 3 minus 2i. Now, on C, we just multiplied by a single term. On D, we're multiplying by two binomials. So when we do this, I do find that it's easiest if we use the box to multiply. So you're going to take your first binomial, 5 plus 3i, write it on one side. You take your second binomial, 2 minus 3i, write it on the top, and we multiply. So when we multiply 5 times 2, it's going to go in this box. So 5 times 2 is 10. Then we multiply 5 times negative 3. That gives us a negative 15i. Then we multiply 3i times 2. That would be a 6i. And last but not least, we multiply a 3i times a negative 3i. That would be a negative 9i squared. But remember, I squared is equal to a negative 1, so that's negative 9 times a negative 1, which just equals a positive I. Once you're here, you combine your like terms. So my like terms are 10 and 9. That gives me a 19. And then my second set of like terms are negative 15i and positive 6i, and that gives me a plus 9i. Sorry, not a plus 9i, a minus 9i. Okay, and that's how you combine the like terms there. So in the second part of this video, I will show you how to use a handheld calculator to get these same answers.